JMath.
Double angles is the next part of grade 12 trig that you are going to learn. So you will see the 4 formulas up there. So all they did is they said, okay, we now know compound angles, but what happens if it was sine A plus A or cos A plus A? And then they came up with these formulas. You would have noticed that cos actually has 3 options. Now, sometimes this can get very confusing because which one do you use? So the more you practice it, you will know which one's going to work and which are not going to work. But let's go through this. Let's try question 1. So the first thing I need to do is I need to see which is it. Is it a sine double or a cos double, or is it actually a compound or something else? So you need to study the format of these double angles. It is on your formula sheet, but you're going to be so much quicker if you already know, oh, this is actually one of the causes, and then expand. Because if you're still going to struggle and page back and forth, you're not going to finish your tests. Okay, so number 1, 2 sine 11 cos 11. So that is in the format of my sine double angle. So I can immediately go and rewrite this as sine of bracket 2 times the angle I'm working with, so 11. So the answer to this is just sine 22. Okay, fairly easy. I spotted the correct pattern. I just rewrote the formula in terms of 11. Okay, question 2, cos squared minus sine squared. So that's actually the top one from cos. And I can then see, okay, that is in the right format. The minus is where it should be. So I can just rewrite this as cos 2 times 11, which is just going to be cos 22 degrees. Okay, I can't do anything further. It's not a special. Don't type it in your calculator and make it a decimal. Then you're going to get 0. Okay, question 3. So once again, this is in the correct format. It is a cos double angle. So I can just rewrite this as cos of 2 times 22, which is then just cos 44. So with number 4, I can just check, is it in the correct format? Yes, it is. 1 minus 2 sine squared. So I can just immediately rewrite it as cos double of that angle. And in this case, 2 times theta over 2 will just be theta. And therefore, question 4's answer is just cos theta. Okay, so these 4 I purposefully made easy, so you can just see how I use the formulas. But now let's go a bit deeper. So with these ones, I just wanted to show you how something extremely small can change the complete answer as to what's going on. And if you don't know your work really well, you will not see these small changes. So please study hard that you can get these marks. Okay, question A. So 2 sine 15 cos 15. That is in the correct format. That is sine's double angle. So I can just say this is sine of 2 times 15, which is just going to be sine 30. And that is just a half. Okay, very easy. Next one, cos squared 15 minus sine squared 15. That is in the correct format. That is a cos double angle. So this is then just cos 2 times 15, which is cos 30. It is a special angle, so root 3 over 2. Okay, great. But now the order changed. So now it's sine squared 15 minus cos squared 15. Okay, so it looks very close, but it is not the same. So I need to make it the same. And in grade 9, you learned the sign change rule. So I can swap the order if I take out a minus. So just going to say it's minus cos squared 15. This stays a minus sine squared 15. And now I know from the previous sum that this would just be minus cos 30. And the answer is then just minus root 3 over 2. Okay, so don't miss that one. With question D, so now it looks the same as question B, but the minus became a plus. Okay, so in this case, it is the grade 11 identity that says sine squared plus cos squared. If the angle is the same, the answer is just 1. I don't need to write anything else. If I notice that, I can just say the answer is 1. Okay, question E, I never want a minus at the start of an expression. So if I can, I'm going to take it away. So in this case, I'm just going to take out a minus 1, and this then becomes cos squared 15 plus sine squared 15. And now you can see it's the previous one, and that just becomes minus 1 times 1. Answer is just minus 1. Okay, so those last 4 looked very similar, but you can see the answers differed quite significantly just based on a plus or a minus or the order. So don't let them catch you out. Okay, question F. So something else you need to know about trig, and I hope you noticed it in grade 11 already, is all your factorization and your algebra and your fraction rules still count even though it is sine, cos, and tan. And this is a prime example of that. So if I have this sum, I need to write out this bracket twice and then FOIL it. So the answer would then be sine times sine just becomes sine squared 15. Then I multiply the middle ones. So it's going to be plus sine 15 cos 15. Then I need to multiply the outer ones, which is going to be plus sine 15 cos 15. And then I multiply the last one. So cos times cos just becomes cos squared 15. Okay, so now if I just rewrite that a little bit, I can say this is sine squared 15 plus cos squared 15. And then the middle ones add up because it's like terms. This will just be 2 sine 15 cos 15. And then if I look closely, this actually becomes 1, and this is my sine double angle. So now I can just rewrite this as 1 plus sine 2 times 15 is sine 30. That is just 1 plus a half, and the answer is 1.5 or 3 over 2. Okay, so we needed to use algebra rules to get to that answer. Question 6. So now we get to a few tricky sums that sometimes seems a bit unfair. So we call this mathematical manipulation. So you need to change what you see so that you can use it, or you need to add things that you don't see so that you can use it. In this case, 6 sine 15 cos 15. Now, I hope you recognize that. We've done a few with sine 15 cos 15, and every time it was the double angle. But now there's a 6 in front, there isn't a 2. Now, this will not be a sextuple answer or something weird like that. It must be a 2. So I can manipulate the 6 and rewrite this as 3 times 2 sine 15 cos 15. And then the answer would just be 3 sine 30, and that is going to be 3 over 2. Okay, so I can break up the 6 as something times 2. So now if we look at B, that concept is going to become very important. Like, again, I see sine 15 cos 15, but now there's nothing in front that I can manipulate or break open as something times 2. But I can say there is actually a 1 in front, and 1 is the same as a half times 2. So it's very sneaky, but this one especially, they love hiding in other sums. So please focus with this one. Write it as a note for yourself. It is going to come up somewhere this year. So sine 15 cos 15. The answer is then just a half of sine 2 times 15, so half of sine 30. That is going to be a half times a half, which is a quarter. Okay, watch out for that one. Question 7, again in the same vein. It looks like the cos double angle, but I'm missing a -1. Now, there's a horrible rule in math that says I can multiply anything by 1, but 1 can be anything, like you just saw with question 6b. Now, the same applies to I can add 0 to anything, but I can write 0 in many different ways. So in this case, I'm going to add a 0, but I need to write it as -1 plus 1. So I didn't change the value of what they gave me. I just rewrote it so that I can actually use the double angle, because there is my double angle now. And I can rewrite this then as cos 2 times 15, so cos 30 plus 1, and it is root 3 over 2 plus 1. And now that I gave the trick away, 7b is supposed to be very easy. It looks like the cos double angle, but I need a +1 in front. In math, I can add a 0, but I need to rewrite 0 as something special. In this case, I want a +1, so I can add a -1 in front to cancel it out. And then this would just be -2 sine squared 15. And then my next line would be -1 plus cos 2 times 15, so that's cos 30. And then that would just be -1 plus root 3 over 2. That's not like terms, so I can just leave it like that. Okay, that was double angle. Started fairly easy, but you can see how tricky it can get later on. So next, we will look at mixing these two and the types of questions that they have come up in textbooks and in past exams.
If this video helped you, please like and subscribe.
JMath.